Alright, using this principle, let's talk about how we'd graph f of x equals root x, then plus 1000. Note here that the plus 1000 is not inside the radical, it is outside of the radical. Now the point isn't to try to graph this using an xy table. The fact that there's this number 1000 here will make this super challenging to try to do this just using a table. Instead, the point is to recall the graph of y equals root x, which is supposed to be a typical graph. I want that to become one of the graphs that you have in your library of, oh yeah, I know what that graph looks like. And then apply what we just said about how the graph would shift. So here's y equals root x, and then that plus 1000, it's going to shift the graph up 1000 units. So there we go. Without doing an XY table, which will be extremely time consuming here, and the numbers will just be so off because of 1000 being such a huge number, I just shift this thing up 1000 units. So y is equal to root x plus 1000 is this graph, the blue part here, just shifted up 1000 units. How about graphing g of x equals absolute value of x minus 318. The minus 318 is outside of the absolute value. So the idea is to take the graph of y equals absolute value of x. That should be another one to be familiar with. It's a V shape, has a sharp corner right at the origin, and then shift this thing down 318 units. So here's that V shape, and then here it is shifted down 318 units. So you'll notice that instead of the vertex, this sharp corner occurring right at the origin, 318 units lower, right on the y-intercept, right on the y-axis, that y-intercept is negative 318.